let's understand the working of a transistor. Okay, now let's try to understand the working of an NPN transistor in specific. Okay, see this particular figure. Now what you have emitter, base and collector. See, there are two junctions, emitter base junction and collector base junction, correct? So there are two junctions. Now in the emitter base junction, what we do, emitter is N type, base is P type. So it's a PN junction. And what we do is we connect these two or this particular junction under forward bias condition. Okay, again I'll tell you, the emitter base junction, it is under forward biased condition. Okay, and we are connecting this to a potential VEE. Alright, now since this is under forward bias, we don't want to give a lot of voltage. We generally give around 1.5 to 1.7 volt, because we know that knee voltage will be there, right? Knee voltage is generally around 1 volt. So we, depending on what type of doping we have, we are going to take around 1.5, 1 to 1.5, take it that way, not beyond 1.5. Okay, now because of this, some current is going to pass through the PN junction. Make sense? Now in the collector base junction, now what we have again a PN junction, and the collector base junction is always under reverse bias. Okay, now we are going to give a potential of about 45 volt for this one. Okay, 45 volt will be there. And now there is a current which is passing through the collector base junction. Now what happens is that there is some current called as emitter current which passes from the emitter to the battery, like what you are seeing in the figure. And then you have the base current IB, then you have the collector current IC. Now guys, what you have to understand is that emitter is giving out the majority charge carriers, correct? So that majority charge carriers, once it starts to move through the circuit, the majority charge carriers is going to split. Okay, and once it splits, what we have is that IE splits into IB and IC. Kirchhoff's current law, IE is equal to IB plus IC. Now since base is very lightly doped and it is very thin, the base current is going to be 5% of the emitter current, very very small. The collector is going to be the majority current, which is 95% of IE. Alright, the total current IE will be equal to IB plus IC, 95% and 5%. Okay, so this is how the working of a transistor is being done. In the sense, the emitter gives out the majority charge carriers as in the current, and that current passes through the emitter, that current passes through the base and the collector. Okay, now PNP also works in the same principle, but then the direction of the current is going to vary, like what you have in the given circuit. Alright, the working is the same. IE is equal to IB plus IC here also. The majority charge carriers are going to move in the same direction. Correct? So working of a transistor is being done this way. Now that you understand how a transistor works, what are the characteristics we have? Okay, so there is one characteristic called as common emitter characteristic. Okay, so what we call as CE configuration or CE characteristic. That you will understand in the next video.